In traditional machining such as milling, it's possible to form complex parts by mounting the stock in a fixture such as a vise. This works especially well because the origin position of an operation is determined at the start of the operation, rather than in some external file. We can get a similar effect with a 3D printer despite not being able to locate stock in the same way. We can't zero the coordinate system, but we can still use fixtures. This allows us to print parts that would otherwise need supports or need to be assembled from multiple subparts. This was printed in two parts. The black part was made by creating a hemisphere and printing it like normal. Nothing interesting happens here. But the blue part is a little more interesting. It was printed in conjunction with a fixture, which has a cutout which is more or less the same shape as the black hemisphere. Here you can see a section view of the fixture and a blue hemisphere. You can see that the upper hemisphere just hangs in midair over the gap beneath it. That won't cause problems because we're going to fill that gap with the other black hemisphere. Export this component as a single STL file. Here's the fixture and hemisphere loaded and sliced in Orca Slicer. Scrubbing through the layers, we can find the last layer of the fixture, and the first layer of the blue hemisphere. While this first layer of the blue hemisphere is chosen, right-click on the layer slider handle and add a pause. Now reslice and export the file. To print the second half of the ball, simply print the file like normal. Halfway through, it'll pause automatically. At this point, add a small amount of double-sided tape to the bottom side of the lower part. Insert it into the fixture, and then continue printing. It's very important that the lower half of the part is exactly located where the upper half will print. The thickness of the tape can cause it to stick up out of the fixture past the correct height, as you can see in this red version. The second step did produce a hemisphere alright, but it's completely mangled. This is probably somewhat due to pressing on the bed and ruining the homing, but it's also due to the top of the part sticking out by a millimeter, causing the print to start partially inside the part. To solve this, you can lower the negative model that's subtracted from the fixture by a small amount. You'll have to test what particular heights work for your tape. I started with 1 millimeter and that seemed to work just fine, but you might need a different amount. You also need to create clearance for the part to be inserted. Without that clearance, the negative area will narrow as height increases and prevent insertion of the part into the fixture. Since this part was a hemisphere, the cross-section let me just create a cylinder. For more complex shapes, such as this spiky object, clearance can be very helpful. I printed this at an angle, as you can see from the color separation, but that meant that it would be very hard to use a simple subtractive fixture. Consider the cross-section of the fixture without clearance. It has all sorts of overhangs that block insertion of the positive part. Instead of subtracting the lower half of the part, we need to form clearance by projecting the lower half of the part onto a plane, and then extruding the resulting shape to form the clearance, which can then be subtracted from the base shape of the fixture. In this particular case, it's also not possible, nor necessary, to use tape to secure the lower half of the part. Your mileage may vary on whether tape is necessary.